Today's really a continuation of section 4.5. There's not a whole lot new, except we're going to be looking at polynomials that have larger degrees. We're still going to use the fundamental theorem of algebra to basically say that whatever degree the polynomial is, that's how many solutions that polynomial is going to have. So the number of solutions is the highest power. We are also going to be using Descartes' rule of signs. This was not that big of a deal before because we were looking at all real number solutions. But today's the day when if you don't use Descartes' rule of signs to determine how many positive and how many negative solutions, you might actually miss solutions. You might not find a solution. So we're going to use Descartes' rule of signs to help us narrow down whether we should test positive or negative solutions. So here's the steps to follow, and it's basically the same as what we were doing before. If the polynomial has 4 terms, see if you can factor by grouping. If you can't, continue on to step 2. Use Descartes' rule of signs. Remember, the number of sign changes tells you how many positive solutions there will be. And then the number of negative solutions just makes it add up to the total number of solutions. And remember, if it happens to be 2, it's or less by 2. So if there's 2 possible solutions, there could also be 0. Find the possible rational solutions. We aren't going to be doing p divided by q because we're going to always have the leading coefficient be 1, blah, 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 blah. So this is just the factors of the constant term. And step 4, test the rational solutions using synthetic division until a quadratic is reached, until you get to a point where it's x squared. We might have to do this step, this cycle, multiple times until we get to a quadratic. Then factor or use the quadratic formula. We haven't used the quadratic formula since first semester, so you may want to write down what it is. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So pause the video if you need to get that written down in your notes. You may want to write it in your notes on this page. Okay, example 1. Find all zeros of each function. This means we are going to be finding the real solutions and the imaginary solutions if they exist. All right, this first one, the first thing I want to do is rewrite this x to the 5th plus 0x to the 4th. Notice there's a missing term in there. Plus x to the 3rd minus 2x squared minus 12x minus 8. This is a long polynomial. All right, it's definitely more than 4 terms, so we can't factor by grouping. It's a 5th degree polynomial, which means there are 5 possible solutions. Of those 5 possible solutions, let's look at the sign changes. We start positive. Oops, I don't mean to draw that. So we start positive. We change to negative here, and then stay negative. So there's 1 sign change. That means 1 possible positive solution, which means there are the potential for 4 negative solutions or less by 2. So or 2 negative solutions or 0 negative solutions. There is a chance that we will have no negative solutions. So we need to test the positives so that we're guaranteed to get a solution. Our possible solutions, if we look at our constant term negative 8, the factors of negative 8 are 1, 2, 4, and 8. And we are going to be testing the positive versions of those numbers. So using synthetic division, our coefficients are 1, 0, 1, negative 2, negative 12, and negative 8. 1, 0, 1, negative 2, negative 12, negative 8. So in case you've forgotten your synthetic division, those numbers come from the coefficients of the polynomial. Okay, we are going to test positive 1. So using synthetic division, drop the first one down, multiply. 1 times 1 is 1. Add. Multiply. 1 times 1 is 1. Add these two together. Multiply. 1 times 2 is 2. Add those. 1 times 0 is 0. Add those. 1 times negative 12 is negative 12. That is not going to give me 0. So positive 1 did not work. If you want to reuse your synthetic division, you simply erase this stuff out, which is a little bit easier for me than it is for you. Now we're going to test positive 2. Drop the 1 down, multiply, add. Multiply, add. Multiply, add, and so on. 2 times 4 gives me 8, and that adds to 0. Remember, that's what you're looking for. You want to get a remainder of 0. Okay, this is the part that's a little bit different. Because we started with x to the 5th, 2 works, which means x minus 2 is a factor. These coefficients, and I'll circle them in purple, become x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 4. So why did we start with x to the 4th instead of like x squared like we've done before? When you're using synthetic division, you're basically taking your you're taking your degree and decreasing it by 1. So this x minus 2 divides out one of those x's. We still have x to the 4th. And what you might notice is x to the 4th, we're going to have to keep going. We're going to have to use synthetic division again. So now it's kind of like a whole new problem. This purple part has 4 possible solutions. Using Descartes' rule of signs, this term starts positive and they stay positive. There are 0 sign changes, which means there are no positive solutions to this purple part, which means there's possibly 4 or 2 or 0 negative solutions. We are really hoping that there's not 0 negative solutions, because then we'd really be done. So let's test the negatives. And this time our constant term is 4. So the nice thing here is that our potential solutions are 1, 2, or 4. 1 times 4 is 4. 2 times 2 is 4. So those are our possible solutions that we need to test. This time our coefficients are 1, 2, 5, 8, 4. 1, 2, 5, 8, 4. And we are going to test first negative 1. We want to test all of the negative solutions. So let's test negative 1. That's negative 1. Add them. Multiply. And add. Multiply. And add. Oh, hey, it worked the first time. So negative 1 is a solution, which means x plus 1 is a factor. We started with x to the 4th, so these coefficients are x to the 3rd plus x squared plus 4x plus 4. You can't forget, we also had x minus 2 up there. Okay, it'd be really nice now if this 4-termed thing would factor by grouping. So let's check to see if it does. Split it down the middle. These first 2 terms have x squared in common. These second terms have 4 in common. Oh, thank goodness, it factors by grouping. If it didn't factor by grouping, we would have to do the cycle again. Look at 3 possible solutions, use Descartes' rule of signs, test solutions using synthetic division, and keep going. Thankfully, because it factored by grouping, we don't have to. So in front, we still have x minus 2 and x plus 1 from all of this work that we did up here. This is now the fully factored form. X squared plus, we can't factor x squared plus anymore. So now let's look at our solutions. X minus 2, that factor, gives us a solution positive 2. X plus 1 gives us a solution negative 1. X plus 1 gives us a solution of negative 1. So negative 1 is doing double duty here. X squared plus 4, we need to set that equal to 0. To undo a square, we square root. So this becomes the positive or negative square root of negative 4. What we need to remember is that the square root of a negative number is an imaginary number. So this splits into the square root of negative 1, which is I. So square root of negative 1 times the square root of 4. The square root of 4 is 2. The square root of negative 1 is I. So one of our solutions is positive or negative 2I. And that's actually 2 solutions. So there are 4 solutions. There's actually 5 solutions because x equals negative 1 is doing double duty. But our solutions are 2, negative 1, positive 2i, and negative 2i. And if we go all the way back up to the top, we're supposed to have 5 solutions. Only one of them should be positive. So if we look at our answers, we have 1 positive real number solution, 1 negative real number solution, and 2 imaginary solutions. For example 2, you are going to need to watch the next video. Make sure you watch the next video.